our final presentation. This year we had the opportunity to work with TWIL Luxury Innovations to create the TWIL Design Labs configurator. So then just some overview about the company is that TWIL specializes in printing UV ink onto thermoplastics and then applying that material onto different types of objects. And this could using textures and things to simulate stone, wood, or leather. And this process also enables the production of really lightweight, durable, and realistic finishes. And it makes it customizable for solutions for high-end interiors like private jets, yachts, and hotels.
Moving into our stakeholders, our sponsors were Chris and Anna Nelson. They're the company owners of TWIL. And then Joel Vlasnik, who is an investor. Our faculty, staff, and our coach was, our project manager was Roland, tribe lead was Zach, and our coach was Alex.
So then for our student team, I'm Cassidy. I was our squad lead and project manager. And then we also have Trevor, who was our development manager. And then the rest of our developers, we had Connor, Peyton, Jordan, and Brandon, who are all developers on our team.
Moving into our problem and opportunity, TWIL Luxury Innovation found a critical bottleneck in interior design. The current process is a manual, inefficient material selection that you then have to render the image so that you could show it off to a client. So this presented the opportunity to build a real-time 3D configurator that produces high-quality renderings of just 3D textures and models. Moving into our product solution, we first built out a sign-up logic that has secured login and subscription. We also had an editor, which is a 3D environment for model selection, texture application, and object manipulation. And we stored all of this data into an S3 bucket as well as a Dynamo database.
So then within our actual editor in the configurator, it allows users to do things like uploading models, selecting, and then saving them. And then it also has access to a giant preloaded texture library that, if needed, also allows for personal textures to be uploaded. And from there, those could be applied to different types of objects within a plane like it's seen here, and also gives them the chance to manipulate them, so like rotating them around or scaling it up or down. We also have a color catalog to change the colors. If you liked the wood texture but wanted it maybe in a different color of wood, you could do that. And then we also had multiple camera controls and a path tracing viewport to kind of see a more realistic mock-up of everything, a little bit better to like simulate real life than just the 3D editor. So we have a little architecture diagram here. At the bottom, you could see our Amplify app. That's kind of like the base of our project. Because then we have our texture storage bucket, which goes to two of our Lambda functions, which will be the process textures and the generate thumbnail. So anytime a texture is uploaded, it goes through those Lambda functions and parses through each of the maps to make sure that it's applying realistically, and then also generating a thumbnail for each of those. And then we also have our model storage bucket, which has the Draco compressor Lambda function. So this just means that once a model is uploaded and then saved into the model table, it's going through that compressor to make sure it's being optimized for use within the program. And then our last Lambda function on the bottom is our change tier that just allows users to change their subscription and then updates in the user database so that they have all those permissions that are needed.
Continuing on to that, our material transformation, we really wanted to make the textures as realistic as possible and allow for plenty of options for users. So we added displacement, rotation, scale, as well as like normal maps and roughness and metalness. This also allows for deletion of textures if it's something that you did not want in there. The value that this presents, it's accessible through a browser, which makes it easy for many people to use. It's real-time photorealistic rendering. Since we use 3JS, it has very high fidelity, And we have a GPU path tracer, which allows for computation of like really highly accurate lighting. We also have an automated cloud processing pipeline. This allows you to compress 3D models using Draco and create EXRs with texture thumbnails. There's also a scalable subscription architecture that goes from free to Diamond, built with a AWS Cognito, and this allows for gating features, blocking storages, and access to specific materials.
Yeah, so just for our team, we had a lot of different learning opportunities with this project. We got to work with new technologies like 3JS and AWS, which I don't think any of us really had experience with before. And we learned how to use those AWS pipelines in different ways, with creating Lambda functions to go from the project to the function to our storage, and then our automatic deployments with Amplify, and then pulling from and saving to the S3 storage buckets. We were also able to build confidence in balancing our technical execution with collaboration, accountability, and ownership. And then tons of learning to ask questions and learning to ask them early. And then just getting that feedback and adjusting our deliverables based on sponsor input to make sure that everybody's going to be happy with the finished product. But yeah, I just want to give a big thank you to everybody who came for the presentation, and an extra big thank you to our sponsors. We had a lot of fun doing this. I think it gave us a lot of cool opportunities. So yeah, thank you very much.